So in the previous video we saw how we could move a bunch of times and stop when we reached a condition was not met. We saw how we could move, for example, 3 times and then stop, because even though the for loop went to 1,000 times, the condition was false once we reached the third step in this case. So you can see Pac-Man moves, he moves again, in each of those cases he moved only because the condition was true, then the condition is false, there's no dots ahead, so he will stop what he's doing there. So is there an alternative? Because looping round 900 times is not terribly efficient. So let's see if we can deal with an else condition. So in the case that we don't want to eat forwards, so we would move 3 times here and then we don't want to move forward, let's decide what we do want to do instead. So let's say we want to follow a line of dots, and the line of dots turns and we want to eat along it. So let's see what that might look like. So this is bear with me a second. So this is unbroken line. So let's say we want to solve unbroken line 1, and we want to do it with about 5 lines of code. So we want to eat all the way along this line. Well, let's turn him right to start with, and then test that. He's now facing in the right direction. So we'll put in our for loop for int counter equals 0, counter less than 1,000, counter equals counter plus 1. Now we put in our if statement, if open brackets, close brackets, the thing to do here, which is to move. This is exactly as we saw in the last video, and the condition was to call main.is obstacle ahead and pass in dot. So he's going to move as long as there are dots. Brilliant. Now there are not dots, so this loop is just going around 1,000 times. Well, what do we want to do? Let's specify an alternative. Let's say to him, if there's a dot ahead, move. If there's not a dot ahead, what else should we do? Well, the symbol for not is an exclamation mark, so this is one way we could do it. We could say this is, or we could use the equals equals operator, is false. So this, we could write equals equals true. In this case we write equals equals false, but don't worry about that, it's optional. So we can test if something is not true by saying equals equals false. We saw that with variables in the previous example. So let's do main dot turn left. So he's going to turn left if there are no dots ahead. Wow, we've suddenly solved the entire map with just a couple of lines of code. So let's see what we did there. We gave him 2 conditions. We said if there is a dot ahead, move. If there is not a dot ahead, if dot ahead is false, so if the condition is not met, turn left. Well, this is quite confusing, and you have to really quite look at it to sort of figure this out. Let's see if we could just write something in English that made more sense. So if there's a dot ahead, move, else turn left. And that actually is exactly what we're looking for. That is the Java code to provide an alternative. So just to prove the point, it does exactly the same as before. In each time it moves, its condition is being checked. It says, check this condition. Is there a dot ahead? True, so move. Else, so if there's no dots ahead, turn left. Now let's see if we can solve a different map using exactly the same code. Wow, he's solved this map as well, using exactly the same code. What about this map? Wow, we've solved any map which has an unbroken line of dots just by using that code. What about broken line? Let's try that map. Right, so we've run into a problem. How are we going to fix this problem? Well, let's just comment out our code. And have a look at the map. So there are occasionally 2 dots empty. So what if we were to eat forward 2 dots at a time? Eat, 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 eat. Because the problem is he eats 1 dot, and there's no dots adjacent to it. So we found a map we can't solve. So let's have a look, see if we can fix this. What would happen if we doubled up his moves? So each time he's going to eat 2 dots. Oh, still doesn't help us. Let's try eating 3 dots. Okay, so that's working. He may fall off the end though. Yeah, he falls off the end. So maybe we need to, for example, count the number of times he's moved. So if he moves up to here, and if he can't find any around him, then he should move forwards too. How would we do that? Well, let's draw it out in Notepad. If dot ahead, move, else, turn. And then we can have another if here. If have turned 4 times, so that's all the way around. Move forward anyway. Okay, so there's our code. Let's see if we can program it. So let's go inside our for loop and paste our code. So if there's a dot ahead, main dot is obstacle ahead, dot, move, else, turn. Well, yeah, that's exactly the same code as we had before. We use turn left in this case. Now, we've got this condition here now we want to check. If we have turned around 4 times, that means we're going to need a counter of the number of times we've turned. So let's take it here, int, we'll call it number of times turned, set equal to 0. Now, every time he turns, we want to increase it. So number of times turned equals number of times turned plus 1. So now we need to check here. What do we need to check? If we have turned round 4 times, if number of times turned equals 4, main.move. So you should be programming along with me so we can see how this is working out in practice. Here's our big repeat. We check to see if there's a dot. We move if there is a dot. If there's no dots, we start turning round, and we keep track of the number of times we're turning round. And if we've turned around 4 times, we move forward anyway. Now there's one thing we have to think about here though. This is only going to move us at 4 turns. What about if we've taken a left-hand turn, which was a valid left-hand turn, and we start eating dots? We need to reset our counter. So let's reset our counter here. It's working. So he moves. When he can't find any new dots, he moves forward anyway. But when he can find new dots, he does eat those dots. So try solving 2 and 3 using the same solution.